In this episode, we're going to look at how to do IPv6 neighbor discovery. I'll show you how to do it and have a discussion of the concepts along the way. In order for a device to communicate with another device, the MAC address of the destination must be known. With IPv6, the process is called neighbor discovery using NDP, and that's responsible for determining the destination MAC address. We're going to gather PDU information to better understand this process. We'll be discussing IPv6 neighbor discovery on a local network, and then we'll look at IPv6 neighbor discovery on a remote network. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on practical configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. IPv6 neighbor discovery. I have the packet tracer lab open. On the left side, I have the normal packet tracer window that's got our topology and has all our devices we're going to interact with. On the right side, I have the packet tracer activity windows that have the directions and instructions. The bottom right is the original packet tracer activity that comes with the packet tracer file. The upper right is the Word document of that packet tracer activity window down below. I use the Word document. That way, when I get to the questions, I can answer it and I can save the Word document at that point in time. We have our addressing table here. Notice that we have all the devices listed except for the switches. Switches don't get IP addresses once again. Our objectives, we're going to use IPv6 neighbor discovery on a local network, and then we're going to use it on a remote network as we look at this information. Part 1, IPv6 neighbor discovery on a local network. We're going to obtain the MAC address of the destination device on the same network. Step 1, check the router for any neighbors that it has discovered. Click on the RTA router. Select the CLI tab, it's the only tab that's available, and issue the command show IPv6 neighbors. I'm going to hit enter a couple times, give me a clear working space. Type in enabled, get us into privilege exec mode. Once we're in privilege exec mode, we can type in the command show space IPv6 neighbors. And there are no neighbors listed. If there were, we could go ahead and enter the command clear IPv6 neighbors. That would clear out any neighbors we have, and then we could just simply do the show IPv6 neighbors, and it would show us any of the information. Once we're done with that, we can go ahead and close that window. Click on PCA1. Go ahead and click on PCA1. On the desktop tab, open up our command prompt. We're on the desktop tab, open up our command prompt. There. Switch to simulation mode and capture events. What we want to do is change from real time to simulation. That's in the bottom right of our main packet tracer window. We're going to go from real time here to simulation. Go ahead and click on simulation. Click the show all none button in the lower left part of the simulation panel. Make certain that event list filters visible event displays none. Now in the simulation panel, this is the simulation panel. In the lower left is the show all none button. Down here, this is the show all none button. Go ahead, click on that, and notice it is changing. Click here, this is all the events that it's going to show. We want it to say events list filter, visible events, none. That is what we're looking for. Step E, from the command prompt on PCA1, open up PCA1, we got our command prompt here. Issue the command ping-n1. So we're going to ping once to this IPv6 address. This will start the process of pinging to PCA2. Ping space minus n space 1. It's just going to ping once. Normally Windows pings 4 times. And then the IP version 6 address, 2001 colon db8 colon acad colon 1 colon b. That is the IP version 6 address of PCA2. Go ahead, start that. Once again, we are in simulation mode. I'm going to minimize this window. We have started the process. Click the play capture forward button, which is displayed as an arrow pointing to the right with a vertical line. The status bar above the play control should read capture to 150. So I'm going to go ahead and click that play capture forward. Right here, it reads captured to 150. Yours should be approximately that, give or take about 4 or 5, but mine's matched up 150 exactly. Step G, click the edit filters button. Right here is the edit filters button. It's in the bottom of the simulation panel. Select the IP version 6 tab. We have 3 tabs up here. We have IP version 4, IP version 6, and miscellaneous. We want to select the IP version 6 tab and check the boxes for ICMP version 6 and Network Discovery Protocol. ICMP version 6 and NDP, Network Data Protocol. Go ahead and close that window, and we should see about 12 entries. Here I have 12 entries. Shows us exactly what we have. Why are NDPDUs present? Why are Neighbor Discovery Protocol Data Units present? Notice right here we have these NDP, Network Data Protocol. They are present. We have 2 protocol data units. One over here for our ICMP, our ping. That is a very dark maroon color. And then I have a green one here. That is our Network Discovery Protocol. And why are these present? In order for this ICMP version 6, this ping to work, we need to know what our destination MAC address is. This is just being started. We don't know what that destination MAC address is. We have to go through the network discovery process to get that MAC address. Our answer to why are network discovery protocol data units present. In order to send ICMP version 6 ping packets to PCA2, PCA1 needs to know the MAC address of the destination IP version 6 Neighbor Discovery request this information on the network. H. Click the square in the type column for the first event, which should be ICMP version 6. What they're wanting us to do is click on this square right here. Question: because the message starts with this event, there is only an outbound PDU. There is no inbound PDU details here. Under the OSI model tab, what is the message type listed for ICMP version 6? Under the OSI model tab, what is the ICMP type listed for ICMP version 6? If we go in here, layer 3, at the end of this, we have ICMP version 6, echo message type 128. ICMP version 6, echo message type 128. Notice there's no layer 2 addressing. There is no layer 2 addressing. IP version 6 does not need layer 2 addressing for its neighbor discovery. That's an advantage over IP version 4 in the ARP process. Click the next layer button to get an explanation about the neighbor discovery process. Right here is the next layer button. Here is this. The next top IP address is a unicast address. The network or the neighbor discovery process looks it up in the neighbor table. 2. The next top IP address is not in the neighbor table. The neighbor discovery protocol process sends a neighbor solicitation for that IP address and buffers this packet. On I, click the square next to the next event in the simulation panel. Once again, this is the simulation panel right here. They want us to click on the next square. It should be at device PCA1, and the type should be NDP. Right there is NDP. Question, what changed in the layer 3 addressing? Now, comparing it from the previous PDU information window, the destination address is now an IP version 6 multicast address of FF02:1 FF00:B. That's what the change was. The destination address is now in IP version 6 multicast address of FF02:1 FF00:B. What layer 2 addresses are now shown? Over here, looking at our PDU information window, looking at our layer 2, what addresses are shown? They are now showing a source MAC address and a destination MAC address. The source MAC address is PCA1, which is a MAC of 000.00. Okay, starting over 0001.427E .E8ED. Change that actually to an 8. There we go. And the destination MAC address is 333.ff00.000B. There we go. When a host does not know the MAC address of its destination, a special multicast address is used by IP version 6 Neighbor Discovery as the layer 2 destination address. That's what this is that special multicast MAC address here that's used by IP version 6 Neighbor Discovery. Starts off with 333.ff00. J, select the first NDP event, Neighbor Discovery protocol event at switch A. Coming down here, switch A. This is the first NDP event. Go ahead and click on that square. Opens up our PDU informational window. Is there any difference between the in layers and the out layers for layer 2? Looking here at the OSI model tab, comparing, this is the in layers stack, this is the out layer stack. Looking at layer 2, is there any difference? We have an IP address that starts here with E8ED here in the out layers, and we have that special multicast MAC address. Here, there is no difference at this point in time. To answer our question, no. The switch does not alter layer 2 information. It only forwards the frame. Because once again, we have that special multicast MAC address there. K. Select the first NDP event at PCA2. Go ahead and close this. PCA2, our first NDP event. Go ahead and click on that. Click the outbound PDU details. Outbound. What addresses are being displayed for the following? What is the Ethernet 2 destination address? We can look here at the Ethernet 2, the layer 2 frame header. Destination address is right here. That is 0001.427e.e8ed. E8ed. What is the Ethernet 2 source address? Ethernet 2 source address is the next field right here in the Ethernet 2 header. That address there is 0040.0bd2.243e. What is the IP version 6 source IP? Well, we have to go down to the layer 3 IP version 6 packet header. Now notice once again, the information at the beginning is a little bit shorter, but our IP address is 4 times longer. This here is our source IP address. Source IP address is 2001:DB8:ACAD:1:B. That is what our source IP address is. What is our destination IP address? Destination IP address here follows the source. This is our destination IP address right there. Destination IP address of 2001:ACAD:1:A. Source IP address, destination IP address, it's on the same network. The first part is all the same. Our host portions are different. We are sending to different hosts. L. Select the first NDP Neighbor Discovery Protocol event at router A. Coming down here, router A, first NDP event. Why are there no outlayers? Why are there no outlayers here? Well, if we look here, there's no outlayers because our IP version 6 address does not match the router's address, so the packet is dropped. The IP version 6 address does not match the router's address, so it drops the packet. There we go. Click through the next layer button until the end and read steps 4 through 7 for further explanation. Go ahead, click the next layer button right here till you get to the end. Packet is an NDP packet. The device processes it. The ND packet is a neighbor solicitation. The neighbor solicitation targets the IP version 6 address, does not match the receiving port's IP address. The NDP step 7, the NDP process drops the packet. That's what happens. That's why there is no outbound PDU at that point in time. Gets it in, does not match the address, doesn't have to process it anymore. And click the next ICMP version 6 event at PCA1. Here we are, PCA1, next event. The window opens up right here. Question: does PCA now have all the necessary information to communicate with PCA2? If we look here, all the necessary information is the MAC address. Where is it going? That's all we need. We also know, if we look at the outbound tab, we also know the source and destination IP address. Yes, it now knows both the destination IP version 6 address as well as the destination MAC address of PCA2. Question 0. Click the last ICMP version 6 event, add PCA1. Down here, last event, PCA1 ICMP. Notice that this is the last communication listed. So this is the last step that we are doing here. What is the ICMP version 6 echo message type for us? Well, if we look in here, we can see I'm on the OSI model tab. We can see that the ICMP version 6 is an echo message type 129. ICMP version 6 echo message type 129. Click the reset simulation button in the simulation panel. This is the reset simulation button right here. Go ahead and click it. From the command prompt of PCA, repeat the ping to PCA2. I'm going to go ahead and click on PCA1. We have the command prompt here. Once again, the up arrow is our friend. We don't have to retype that all in. Go ahead, up arrow once, hit enter. Next step says you click the capture forward button 5 times to complete the ping process. 1, packet moves from PCA1 to the switch. 2, moves from switch A to PCA2. 3, goes back from PCA2 to switch A. 4 is PCA1 and it reaches its destination. Question: why weren't there any neighbor discovery protocol events? Well, we already did the ping once. The neighbor discovery tables all had that information in there. PCA1 already knows the MAC address of PCA2, so it does not need to use neighbor discovery. There we go. That ends part 1 of this exercise. Part 2, IP version 6 neighbor discovery for a remote network. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Now what we're going to do is we're going to go across our router. We're going to go from one network to another network. Before we do that, we got to make sure to click the reset simulation button on the step 1, capture events for remote communication. A, display and clear the entries in the IP version 6 neighbor device table as was done in part 1. Go up here to part 1. Go look for our clearing our devices. Click on RT1. Go ahead and let's show IP version 6 neighbors. There's nothing in there. Up arrow once again is our friend. Let's just clear it for good luck. Show our IP version 6 neighbors again. There is nothing. We are good to go. We can go back down here to part 2 again. Part 2, switch to simulation mode. We are in simulation mode. Click back and forth. We are in simulation mode. Click the show all none button in the lower left until it displays none. We are currently displaying ICMP version 6 and NDP. We don't want that. Go ahead, clicked it once. Now it's displaying none at this point in time. From the command prompt on PCA1, go ahead, click on PCA1. We have our command prompt. We want to ping only once this IP version 6 address. Ping space -n space 1, and then our IP version 6 address 2001 colon db8 colon acad colon 2 colon a. Go ahead, ping that. I'm going to minimize this window. Click the play capture forward button. Go ahead and do that. It captured it. Once again, we should read about 150 in our captured. If we look right here in our simulation panel, I captured to 150.132. That's pretty exact. You should be within 5 numbers there. Step E, click the edit filters button. Right here is the edit filters button. Select the IP version 6 tab and check the boxes for ICMP version 6 and Neighbor Discovery Protocol. Close that window. It is now displaying all the ICMP version 6 and Neighbor Discovery protocols that this happened when I pinged PCA1 to PCB1. Notice we had to do Neighbor Discovery Protocol once, twice, 3, and finally a 4th time. Click the square in the type column for the first event, which should be an ICMP version 6. Right here is the first event. I'm going to go ahead and click on the square. Brings up our information. Because the message starts here, there's only an outbound PDU. There's no inbound. We didn't receive anything in. We started the ping right there. Notice that it's missing layer 2 information. We don't know what that is because we haven't went through the neighbor discovery process at this point in time. Click the first NDP event at device PCA1. That happens to be the second line down there. I'm going to go ahead and click on it. Opens up our PDU information window. Question: what address is being used for the source IP address of the inbound PDU? Well, if we look here, what address is being used for the source IP address in the inbound PDU? Look here, we have our outbound layers, we have our header, we have our source IP address. Our source IP address here is FE0 ::2001 :427FF FE7E E8ED. That is a link local address. That address is available to any device on the local network. And so our answer reads the link local address for PCA1, and that is FE80 ::2001 :42FF FE7E E8ED. IP version 6 neighbor discovery will determine the next destination to forward the ICMP message to. Click the second ICMP version 6 event for PCA1. Looking down here, PCA1 ICMP version 6, that's the first one. Down here is the ICMP version 6, the second one for PCA1. Go ahead, click on that. What MAC address is being used for the destination MAC address? Looking here at the OSI model, our layer 2, this is where our MAC address is. We have the source where it's starting and our destination. Our destination MAC address is this one right here. Our destination MAC address is 000.1.427E. And the last octet is E8ED. That is the destination MAC address that's being used. That corresponds back to the gig 0/0/0 interface of router A. Click the next ICMP version event at device RTA. Looking down here, here's RTA, ICMP version 6 address. Go ahead and click on the square right there. Notice that the outbound PDU from router A lacks the destination layer 2 address. The outbound layer here doesn't have any MAC address there. This means that the router A once again has to perform network discovery. Because we went into router A, our destination MAC address was on router A. Now, in order to get to its destination, we have to rebuild layer 2. We have to re-encapsulate it. And that's what we're doing here. We have to do neighbor discovery for the interface that has this layer 6 network on it because the MAC address does not know it. J, skip down to the first ICMP version 6 event for device PCB1. Device PCB1, scrolling down right here, we want the ICMP version 6. Nope, that's NDP. PCB1, here is our first ICMP version 6. There. What is missing in the outbound layer 2 information? What's missing here in the outbound layer 2 information? That there is our destination MAC address again. We have to determine that from our IP version 6 address. What is missing here? The destination MAC address must be determined for the IP version 6 destination address. There we go. Destination correctly. The next few NDP events are associating the remaining IP version 6 to MAC addresses. The previous NDP events associate MAC addresses with the local addresses. Skip to the last set of ICMP events and notice that all the addresses have been learned. So skip to the last ICMP, that's the bottom 3, and notice all of the addresses are there. All of the outbound addresses are there. We know all the MAC addresses. We know all the processes. And notice all the information was filled out. None of them were blank. M, click the Reset Simulation button in the simulation panel. Once again, right here is the Reset Simulation button. From the command prompt, the PCA, open that up. Repeat the command to ping PCB1. Once again, your up arrow is your friend. Here's that address. Goes through the process. Or actually, it doesn't. We're in simulation mode. Click the capture forward button 9 times to complete the ping process. Can go ahead and minimize it. We are on PCA. Click it once. PCA sends the PCA1 sends it to switch A. Switch A sends the PDU to router A. Router A then sends it to switch B. Switch B sends it to PCB1. PCB1 then replies to that neighbor discovery request. So it sends it from PCB1 to switch B. PCB sends it to router A. Router A sends it to switch A. Switch A then sends it to PCA1. Gets it to its final destination. Question: why were there any NDP events? Was there any neighbor discovery events? If we look through there, all of these were ICMP version 6. We did not have to do any of the neighbor discovery because we just did a ping before that. And that ping did all the neighbor discovery. We entered in that information into our neighbor discovery table. All we had to do was look that up. We didn't have to go through that whole entire neighbor discovery process. So were there any NDP events? No, there were not. Click the only PCB1 event in the new list. Looking here, PCB1, click on the square, brings up our window. What does the destination MAC address correspond to? In the outlayers, destination MAC address. We start here. This is our source. We're going to the destination. The destination, and once again, we are looking at going from PCB here up to our default gateway. It's to the interface on this device. What does the destination MAC address correspond to? The router interface G0/0/1 on router A. There we go. Why is PCB1 using the router interface MAC address to make its ICMP protocol data units? Once again, we are using that MAC address because that's our default gateway. That's our exit off of our network onto another network where our destination IPv6 address is. Because the destination device is on another network, PCB1 addresses the PDU to the default gateway interface MAC address. Router A will determine how to address the PDU at layer 2 to send it towards its destination. There we go. Step 2, examine router outputs. Return to real time. Down here, we're going to leave simulation mode and go into real time. Go ahead and click on real time. Completes that ping there. How many address? Oh, sorry. B. Click RTA and select the CLI tab. That's the only tab we have available. Enter the show IPv6 neighbors address. You can enter a couple times because it's some clear working area. Up arrow's your friend. Show IPv6 neighbors. I'm going to expand this window a little bit sideways so we have better formatting. There are 4 addresses listed here. We have 4 addresses listed there. What devices are these addresses associated with? These addresses are all associated with PCA1 and PCB1. Now with IPv6, you can have global Unicast addresses. Those are addresses that you can use anywhere out on the network to reach a certain IPv6 address, reach a certain device. We can also have link local addresses. That is only addresses that are usable on your local network, on your local link there. And so that's why we have 4 addresses but only represent 2 computers. Are there any entries for PCA2 listed? Why or why not? All of these addresses here are for PCA1 and PCB2. None of them are for PCA2. No, there's none available. Why? PCA2 has yet to communicate on the network. Ping PCA2 from the router. In order to ping PCA2, go in there, ping, and then we have to put in our PCA2 IP address. If we look here in the chart, and just happens to be up here, this is our IPv6 address for PCA2. Go ahead, type that in, 2001:DB8:8 ACAD:1:B. It will go through, it'll ping it. It pinged successfully 5 times for us. Issue that show IPv6 neighbors command again. Up arrow is our friend. Go ahead and enter it. And now we see we have a entry for the Unicast address, global Unicast address of PCA2. The answer here, once again, is yes. The IPv6 address and MAC address for PCA2. There we go. Reflection questions. Looking here. When does a device require an IPv6 neighbor discovery process? We need that when the destination MAC address isn't known. The process here is similar to IPv4 ARP. When the destination MAC address is not known, this process is similar to ARP in IPv4. There we go. How does a router help minimize the amount of IPv6 discovery traffic on a network? It keeps track of that. It builds a neighbor table so we don't have to go through and do the neighbor discovery process over and over. It builds a table. That way you can just look at the table and then send it on. The router keeps neighbor tables so that it does not need to initiate neighbor discovery for every destination host. Keeps that table, builds that table. Question 3, even though it's labeled question 1 here, question 3. How does IPv6 minimize the impact of neighbor discovery process on network hosts? It uses a special multicast address, so only a handful of addresses would be listening for that neighbor discovery messages. IPv6 has a specially crafted multicast destination MAC addresses, which includes portions of the node address. We help craft it, and we're only listening for certain pieces and parts. That minimizes that traffic. It uses multicast address so that only a handful of addresses would be listening to the neighbor discovery messages. IPv6 creates a specially crafted multicast destination MAC address, which includes a portion of the node address. Last question, number 4. Once again, it's labeled number 2, but this is actually question number 4. How does the neighbor discovery process differ when a destination host on the same LAN and when it's on a remote LAN? When a destination host is on the same LAN segment, only the device that matches the IP version 6 address responds, and other devices drop the packet. When the device is remote, the default gateway device, which is usually a router, provides the MAC address of the interface on the local interface, the interface that's on that network, for the destination MAC address, and then searches for the MAC address on the remote network. The router will then place the responding IP version 6 / MAC address pair in the IP version 6 neighbor table, similar to an ARP table in IP version 4. That ends Packet Tracer Lab 9.3.4 IP version 6 Neighbor Discovery. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.